Hey everybody, today we're doing an example of finding critical values of a function. We're going to look at f of x equal x squared minus 3x to the 2/3. When we find critical values, we're asking where does the function have a derivative that either is 0 or does not exist. So we really need to check two separate things, both related to the derivative. The reason we care about critical values is that these are our only candidates for local maxes and mins. So if we find them, we'll have a short list of places where the local extrema can occur. Great, so let's get to it. We take the derivative of this, one piece at a time. X squared, the derivative is 2x. 3x to the 2/3, the power of 2/3 comes down. 2/3 times 3 is 2. Reduce the power by 1. 2/3 minus 1 is negative 1/3. Okay, so right away, I see a value where this function does not exist. Because x to the negative 1/3 is 1 over x to the 1/3, this will not exist when x is 0. Can't divide by 0. Great. Now we need to know where the derivative is equal to 0. So I'll just set f prime equal to 0. Okay, so to solve this for x, first of all, I want to cancel out this 2, divide both sides by 2, easy. And then I'm going to move this part over to the other side. I'm going to add the 2x to the negative 1/3 and put it over here. I do that, I divide by 2, I get x to the negative 1/3 equals x. Okay, I'd like to have all the x's on one side. I'm going to multiply both sides by x to the 1/3. So I get 1 equals x to the 4/3. Now, to finish solving this, I'm going to raise both sides to the 3/4 power. Because if I take the right-hand side to the 3/4 power, I'll be multiplying the exponents. X to the 4/3 to the 3/4 will be x to the 1st. So, x on the right, on the left, again, raising it to the 3/4 power, 1 to the 3/4, so x is 1. Now we have to be a tiny bit careful here. Think about this right-hand side. What this is saying, x to the 4/3, is take x, raise it to the 4th power, and then take the cube root. That's what this rational exponent means. Now what happens when you raise something to the 4th power? Well, everything becomes positive. Even power, even exponents are going to kill any negative sign that you might have. So when we raise both sides to the 3/4 here, we have to be a little bit careful because we've ruled out the possibility, really, that x could be negative. We have to take that back into account here. Long story short, we get a plus or minus 1. Just as when you've got x squared equals 1 and take the square root of both sides, you got to have that plus minus. Same as when you do it here with x to the 4/3. Okay, overall now, we have critical values of x equals 0 and x equals plus or minus 1. 3 critical values. Let's finish this by seeing a plot of this. I'll pull that up. Great. So now what you're seeing is the graph of f of x equal x squared minus 3x to the 2/3. At x equals 0, you can see the place where the derivative does not exist. In fact, you've got a cusp. Also, a vertical tangent, reflecting the fact that in our derivative here, 2x minus 2x to the negative 1/3, we're dividing by a 0. Also, at x equals 1 and negative 1, we see horizontal tangents. Those are the places where the derivative equals 0.